Okay, in the last video I was looking at boost, so I will move on, and I'll move on to, because boost was basically the air we're going to get, I will move on to the actual fuel we're going to get. And we immediately run into a problem in the sense that if we look at duration maps have rail pressure, this massive number here, and very often the injection quantity is a volume. In other words, it's measured in millimeters cubed or milliliters. So this is actually the volume of fuel. Now that will be fine because the injectors are measuring a volume, and so they can open for a fixed amount of time, a certain amount of fuel will go through. But the problem is, of course, that all the figures we've looked at before this are either torque based or injection quantity based, but based on milligrams per cycle and not based on millimeters cubed. So in order to make sense of the things, we need to get our head in gear. We need to stop and say, what does that mean? Well, a rough rule of thumb is this magic number of 1.2, which is more or less the diesel density, or the density of diesel fuel. So if we know we want more or less there 74 milligrams of fuel, if we multiply that by 1.2, that will give us 88.8 millimeters cubed of fuel. So in other words, we know the amount we want. We want roughly 74 milligrams, and now we know that it more or less means we want 90 millimeters cubed. So it's as simple as that. So we know that we roughly need 90 millimeters cubed. So what I've done is I've put there 90 millimeters cubed because that's what I'm likely to want. And again, I've used Excel's forecast. So I've looked in the formula, found the forecast formula, and used it to forecast new values for 90. So it's using all of these values here up to 78, and then it's using these values for time, and it's saying if I calculate the difference between all these little bits all the way along, each time there's a difference, if I calculate all those differences, I can make my best guess at the next difference and therefore the next value, and the next value it's come up with is 5210, and so on. So they are the new values that it's come up with. And once again, as before, we can't just add that on the end because it would make the map the wrong size. So what I've decided to do is take one of these out, and I've taken out 1.3. You can sort of see why. I mean, there's a lot bunched together here. I could have taken out 0.5 or 0.8. I've just chosen 1.3 at random. So I've taken that out, and then I've cut and pasted the rest. So in other words, I've taken all this lot, and I've just cut it and pasted it. I'll just escape from that a minute so that we don't get muddled up. So I've put it in down here. So 1.3 is now gone because this is on top. So 1.3 is gone completely. So I'm not leaving any part of that axis behind. I've taken out the axis and the data, which left me an empty space, which I highlighted here in yellow. So I was left with an empty column. And then all I've done is I've put those numbers, my new numbers, in, because they've all shifted over, that empty space. So there's my new numbers in my empty space. So now I've got a new duration map, and the new duration map should allow me to go all the way out to 90 millimeters cubed, which I'm hoping is about 74 milligrams. So with a little bit of luck, I've now got my requirements as torque and injection quantity sorted, and I've now got the air sorted, and now I've finally got the injection quantity sorted. So the actual amount of fuel as a duration of injection I've got sorted. So with a little bit of luck, this is all sorted. So I should be okay. So I should be pretty much ready to go, and I should be able to try this map in the car. I do need, of course, to stop and think about something which is fairly obvious, and I'll come back to that in the next video.